The recently released Gemma 270 million parameter model has quickly acquired the reputation of being the most useless model in the Gemmaverse.
Social media is awash with such memes.
But could this be just because you are using it for the wrong purpose?
This seems like grading a fish for how fast it could climb a tree.
So let's fine-tune it for a specific task, like a medical Q&A, and we will use UnSloth, which is our favorite tool for fine-tuning.
So let's get started.
I will be running the fine-tuning notebook on Windows. It is a very simple process and anyone can just get started with it. I have already made a video showing how to install UnSloth on this machine. You will see the link pop up here, or I'll share it at the end of this recording. But first, let's understand what task we are fine-tuning. We will look at medical Q&A, which is the MIRIAD dataset. It is very recently released and has 5.8 million Q&A. These Q&A are generated from scientific research. Let's have a walkthrough of the generation process. The MIRIAD dataset leveraged Semantic Scholar by searching for the term medical. This gave a list of 2.5 million scientific articles and research papers. The top 894,000 were selected and processed through GPT 3.5. Each article was segmented into passages of up to 1,000 tokens and was processed using GPT 3.5 Turbo using a structured prompt. The detailed instructions asked the GPT to provide a Q&A pair which was self-contained. The question focused on medical and biomedical facts that could be answered solely using the data from the source passage. The initial generation provided around 10 million pairs, which were passed through a QC process to reduce them to a high-quality corpus of 5.8 million request-response prompts. These Q&A pairs are visualized using Atlas. The MIRIAD spans 56 medical topics and disciplines, providing a comprehensive view of medical and biomedical knowledge. I can filter them to a specific topic like asthma, and then select only those Q&A pairs which are related to behavior and psychology. The Atlas configuration allows me to click any of these points and then read the source material. Now, since we understand what the task is, let me reiterate it and establish a baseline. When I say we will establish a baseline, it means we will go on Ollama and prompt the Gemma 3 270 million model with the medical queries. This will be then compared with the fine-tuned model when it is completed. Let's check the first medical query. It seems the model has refused to answer our question. Let's try the same question again. This time it provides an answer. We will copy this statement and check with ChatGPT and try to verify it. As you can see that some parts of the response are hallucinated. They are inconsistent with medical knowledge. While this might not be the gold standard way of baselining, this gives us some kind of a benchmark on the consistency of the model's output.
Since our monkey brains have been now activated, let's start with the actual fine-tuning of the Gemma 270 million model.
We first start by importing UnSloth and the fast model function. We will also do the admin stuff of understanding what version of CUDA is installed and the GPU that we are using. Using fast model for loading the model weights, we use the Gemma 3 instruction tune model and use a maximum sequence length of 2048. This defines a context length for the training of the Gemma model. The higher the maximum sequence length, the higher the context that you can take. But it also requires a higher VRAM. Now we take the model that we have instantiated in the previous step and wrap LoRa using the UnSloth PFD API. The intuition is that instead of training all the billions of weights, we only train a few small low-rank matrices attached to certain layers. Use of a PFD model while fine-tuning saves us a huge amount of compute and VRAM. R is equal to 128 determines the low rank decomposition. Typically, higher value means you require more VRAM for training. You can, if you have a smaller model or an older GPU, you can use smaller values over here. Then we set the LoRa parameters like dropout and alpha, which amplify the impact of LoRa module and make the fine tuning more efficient and faster. We are also not training the bias parameter to speed up the process. The random state is set to a certain value for reproducibility. In this next step, we are ensuring that your training data is in the same format that the model expects. In this case, we wrap the Gemma 3 tokenizer with the corresponding chat template, which is shown here. Next, I import the dataset utilities, check the verbosity, which is at level 30, doesn't mean much, and I load the dataset. Note that I have used a local cache directory. If you didn't mention this, it will install it in the Hugging Face default directory, which is on your C drive. The split I take as train is equal to 1000 train. So this will download all the 5.8 million samples. And if you go into the dataset folder, this is in the pi-arrow format. If you check this, this will have a total size of 360 GB because I have downloaded the entire dataset. Instead of downloading the entire dataset, I could always have split it into smaller varieties like only the first 10,000 variety, or I could do a 1% over here to download only 1% of the data set. This is ways of is being more efficient in terms of if you have lower compute capacity or lower storage, you can determine what can be what amount of data that you want to train on. Let's check one of the samples. As you can see, this has a question ID, the paper ID, and the paper URL. It also has the question and answer. It will have the passage text from which the question and answer were created. So convert to chat.ml is one of the data pre-processing step which we use to convert the data into a chat.ml format. Post that, we will use a formatting prompt function which will convert the data into a text prompt which the model can consume. This has the right tokens, right special tokens which are used by the Gemma 3 template. So this is how the format looks after our pre-processing steps. You have added part as the conversation, which has the content, the system user and assistant prompts, as well as the text, which is the prompt which will be sent to the model. We are using the SFT trainer for RL learning tool for fine-tuning our instruction models. This model we will train for 5,000 steps, which is a way for us to manually control how much of the fine-tuning that we are doing. And the learning rate is kept at 2e raised to minus 5, which is not that high that it can cause a catastrophic forgetting. We also use per batch size of 8, accumulation of 1, and warm-up steps of 5. So it takes 5 steps to warm up to the learning rate. Weight decay is 0.01, and these are all regularization parameters. We also set the seed so that we can reproduce the result in another run. And the number of data set processor is one of the things that we look at. We can increase it to 4. It depends upon the number of CPUs that you have, which can take up this bandwidth or take up this compute load. Let's see what happens. But multiprocessing gives me an error where some process has died due to mapping operation. So to debug, let's disable multiprocessing. So I have moved this back to 1, which was the default, and I will run it. This is a tokenizing step which takes place, and it takes about 20 minutes to complete. This is the interesting part, because here we are asking the trainer to only update the loss function only when the assistant replies, and not to waste system resources on predicting the user and system components, which are static in nature. This speeds up the training process while saving on memory. I will now start training this, and once the training has stopped, I will use these steps to save it locally as well as push it to the Hugging Face repo. As you see now that this model has been pushed to my repo on Hugging Face, you can check some of the models that are available out there. One of the things that I couldn't do during this process was converting it to a GGF model, which will allow you to import it directly into Ollama or host it on LM Studio. That is something I'm facing a problem. It might be, and once I get that fixed, I might have I'll push out another video out there. Thanks for watching, and do like and subscribe to our channel. Thank you.